Okay, here we go. One lesson that covers everything that we've talked about in this chapter, and partially last chapter, I guess, too, Solving acute, no, they don't have to be acute. Oblique triangle problems. What that means is any kind of triangle you want, we can do it. And here's the logic I've been building up. Are we solving with a right angle triangle? If the answer is yes, your two weapons are SOHCAHTOA and Pythagorean theorem. There's actually a third weapon. Yes. Sum of the angles of a triangle theorem. So you could use that as well. Yeah? Now, if the triangle's not right angled, the last 2 days we've spent learning we can handle that too. If you have an angle and the opposite side, you can use sine law. If you don't have an angle and opposite side, you can use cosine law. Now, if you had a technically person in the group, you know what the technically person are? Well, technically, Mr. Top, technically sine law and cosine law come from the stuff over here by breaking it into two right angle triangles. So technically, this is using right angle triangle stuff, but you have to use it in a specific way. And there's a third weapon over here. Sum of the angles of the triangle theorem. That's going to be true all the time. So it really should be on these charts. But we're really trying to keep the chart simple, I think, is the goal there. Keep the chart simple thinking. Right angled, yes. Pythagorean theorem, SOHCAHTOA. Right angle, no. Sine law, cosine law. I'll be teaching that throughout the lesson while I do some more word problems. You ready? The white cue ball is 55 centimeters from the red cue ball. Now, the way I taught word problems is to read through it once and don't get excited. That's what I believe is the thing to do. Read through the whole situation. I don't know. In geometry sometimes, put the information on as you go. The white cue ball is 55 centimeters from the red ball. All right, I'll put that right on right now. Don't wait around. Let's start to build the situation as we go. "55 centimeters. Good. And the white cue ball is 55 from the red and 62 from the black. Can you see the triangle developing here? As soon as you have the measurement to two different things, you're automatically building a triangle. The line segment from the red to the white cue ball and the line segment from the red to the black cue ball form an angle of 82. Hold on, I got to read that again. I'm not joking. That sounds like I'm being a teacher and going, oh, read it again. No. Me personally, I got to read that again to know what's going on. The line segment from red to white, I'm going to highlight that. From red to white, and the line segment from red to black, those two make an angle of 182. That highlighting stuff really helped. Just reading it did not help me at all, but maybe you're better than I am at reading these things. There, that's 82 degrees. How far apart are the red and black billiard balls? I'm going to call that B. Call it whatever you want. I'm less scared of B than the other letters. My A's look like 9s. Little c looks like big C. If you let me choose, I'll go B. But what mistake have I made with my B? That should have been little b. Yes? We're going to stick with the way the formulas are. That's little b, and that means this angle over here is big B. So here we go from our flow chart. Don't peek at it. Is it right angled? No. Well, it could be, but if we don't know what it is, we can't use the right angle stuff. So we're over to sine law and cos law. Can it be done with sine law? A couple people saying yes. Yeah, I've got the two opposite ones. So there's the whole deal. lots of things written about sine law where you need two angles, non-contained sine, this, blah, blah, blah. No, it's not that complicated. It's this complicated. Ha! Random lasers on my screen here. Sine law. And I did try to convince you that cosine law was easy as well, but I'm hoping you're finding them reasonably interchangeable. They're just different. So I'm going to call that A and little a. Good. So then I can go after the B's. No, I can't. I can't go after the B's. I got to do C first. This is some of the problem solving I was trying to teach before too, which is like sometimes you can't do what you want to do. So just do something and hopefully the situation improves. So this is big C and this is a little c. I guess I'm going after big C. That's what I can do. And the notes cleverly tell you put your unknown on top on the left. Yes? So this is sine C over little c equals sine A over A. So I'm going after C over little c. Sine A is sine 82 over 62. Now I've taught it both ways now. I'm going to do all the steps this time. But it's possible you're going to skip, and you'll see when I do this, I'll show a way to skip ahead if you really know what you're doing. I'm going to cross multiply 62 sine C equals 55 sine 82. And then I'm going to isolate for sine C, and I get 55, and I'm going to put sine 82. I'm going to cleverly put the 62 over here so that people can maybe see my shortcut. If you put the unknown on the top on the left, maybe you don't have to cross multiply. You could just bring that 55 over. If you don't see that, then don't do that. How much steps did it save me there? One stupid step. It's not worth it. It's not worth it if you don't really see what I'm doing there. And then we've been talking about hammering that into your calculator. Let me find my calculator. Where did I put it? Into GUI mode. 55 sine 82 divided by 62. You try it to make sure you and your calculator are friends here. .878. What's happening? Tim? Gotta do the inverse of Mr. Todd. Inverse sine. So when you get ridiculous answers like that clearly are not correct, when doing homework, what you'll do is you'll go, what am I doing wrong here? When it happens on a quiz or test and you're running out of time, just go with it. Write it out. You go, I know something's wrong here, but I'm going to show the steps so I get all the possible marks I can get, especially as that clock winds down, yes? But when you're doing homework, you're like, no, stop. I got to figure this thing out. Now I'm going to show, did we talk about the answer button in class yesterday? Yeah, so I can survive this. I like typing this all in, but I can survive this by going, oh, wait a minute. Sine inverse that answer that I just had on the screen. Handy button as you move along there. And now I get the answer, 61. You can't round twice, friends. You can't take this 5 and round that 4 up and then use that to round up. Rounding doesn't work that way. Do we agree? If this was money, and I'll just cover that up, 61.45, it's closer to $61 than it is to $62. You can't play rounding games and somehow turn this into $62. You can have 61.5, yes? But not 62. I didn't mark it wrong when people did that, but I was like, I don't think so. Also units. Some people, not very many, left units off or got the units wrong. I did that highlighter thing. I didn't take any marks off in the quiz. I just highlighted the units. So if you see my blue highlighter, that's me going, on the test, I'll take marks off if you don't have the units right. But final warning. All right. Ooh, my diagram's got a little messy here. This here is 61.5 degrees. Now what? Did you get 61.5? Oh, it's supposed to be C. Thank you. I thought you were shaking your head on my 61.5. Oh, I have room for that. 61.5 degrees. Is your diagram way too small for this? Yeah, draw big diagrams. That's my fault that the diagram in there isn't big enough. But when you're doing your homework, draw big diagrams so you can fit this stuff in. Okay. That's not what I was trying to do. I was trying to get side B. Yeah. As soon as SATT pops up, use it. So I can get angle B by going 180 minus the original 82 minus the new 61.5, 143.5, 36.5, and then put that on the diagram. And experience tells me now I can use sine law or cosine law. I can do whatever I want because I've got enough information. Once you get down to that last one, you've got choices. I'll use cosine law just so I'm teaching both in the same example. Yes? So now what am I going after? Finally, after B. Who's got this? Without peeking, B squared equals if it was Pythagorean theorem, yes. But because it's not right angled, I'm using cosine law.
B squared equals A squared plus C squared minus 2AC.
Big B. She's done really, really well. And the hesitation actually probably helps some of you to go, which angle is it? Because a lot of people have, like, for memorizing this, and we're going to give it to you, which I don't think is the right thing to do, honestly. I think memorizing it really helps here to get your homework done faster and to get the test done faster when you know this. When you go B squared equals A squared plus C squared, it's not as bad as it looks, right? Because that's the Pythagorean theorem. Minus 2AC cos B. And when I proved it yesterday, you found out the reason it looks like Pythagorean theorem is it comes from the Pythagorean theorem. I was using the Pythagorean theorem to get it. And even if you didn't follow the whole proof, it was good to see that, to go, that's why it looks like it does. It's the Pythagorean theorem with a little adjustment. Actually, I see it the other way, friends. I see it as this is the theorem that happens to simplify down to B squared equals A squared plus C squared if the angle's 90. Food for thought. Anyways, B squared, I find cosine law less complicated than sine law. Me personally, I just jam them all in there. What do we got? A squared, 62 squared, plus C squared, 55 squared, minus 2, 62, 55, cosine 36.5. Let me just double check that. I typed that all, that I got all that right. 62 squared plus 55 squared minus 2, 62, 55, cosine 36.5, and I get equals, I'm going to make the same mistake I did yesterday because I'm worried it's the mistake you're going to make. And type that all in, and then I'm going to freak out, and then somebody's going to fix it for me. Be ready if you already know what's going to happen here. Somebody already said it. I already know what the problem is. Times cos 36.5. 1,386. People yelling it. 6, 9, 62, 11. Wow. The first ball's 55 centimeters away, the next ball's 62 centimeters away, but they're actually 1,386 centimeters away from each other? No, they are not. Square root. So I got to square root that thing. So B equals, and again, I'm going to use my fancy answer button. Square root of that answer equals, do you get 37.2? Probably. Centimeters, friends. Don't make me take a unit mark off, please. It'll make me sad. There'll be tears on your page from me going, I'm really sorry. I can't give you all the marks. You didn't put the units down. I don't want your grade 11 teachers to hate you, so I will do it now. I will take the mark off. Is it okay? Still typing away, working it out? Or... You have a question? It is a good example. Looks tough, and then you can't even do what you want to do. Then you got to use sine law, sum of the angles of a triangle, cosine law. I could end today right there. That would be a good lesson to go. And you may have to use all that stuff in a particular question. So be ready with all of those weapons on your tool belt, ready to go. You know, like legendary scar, grenade launcher, whatever you got to survive this Fortnite situation. Is this too old a reference? Is Fortnite gone? Was it ever? Do you know what Fortnite is? That's true. Sorry, for a while Fortnite was this game. Nobody plays this game anymore? Yeah, you went into, you parachuted onto an island or something like that. All right. Here we go. No diagram started this time. We can draw it big. While flying a helicopter, a pilot spots a water tower and a monument. A monument? Who comes up with this stuff? The water tower is 48.8 kilometers away from the helicopter, and the monument is 5.6 kilometers away. The water and the tower and the monument are 7 kilometers from each other. Oh, well, I guess things aren't that complicated. I'll draw a pretty big diagram so that we have room this time to label this thing. And what am I going to do? I'm going to try and be clever here. Helicopter. H for helicopter. See, isn't that easier when we start using the letters that are in the question? Spots a water tower. W is one of those dangerous letters again that doesn't look different, big and small, so I went with big W. And a monument. There's the 3 items in my picture. It says the water tower is 4.8 kilometers from the monument. The water tower is 4.8 from the helicopter. Yes? Oh, I said it wrong, didn't I? The water tower is 4.8 kilometers from the helicopter, and the monument is 5.6 kilometers away. The water tower and the monument. Oh, I put that in the wrong spot, didn't I? Jeez. Yeah, could be. The water tower and the monument are 7 kilometers from each other. Did I finally get it right? The water tower is 4.8 from the helicopter, yes. And the monument is 5.6 kilometers away. Yeah, no, they will not be phrased like that. I'll be very careful. I don't want it to be confusing. I want to describe it accurately. Yeah. He's like, I wasn't confused. Mr. Todd, you were the only one that was confused. All right. Draw and label the non-right triangle and solve for the angle in the point of view of the pilot in the helicopter. Here, this is the angle we want to know, angle H. Is it right angled? No, the question was very specific. It's not right angled, friends. Do we have an angle and a matching side? We don't have any angles. We're going to have to use the special version of the formula, which will be on your sheet, and if you love it, then I love you, I love the formula, everything. I don't do it that way. Here's what I do. But you can use the formula, okay? The formula is going to come up on the page here as I do this. I go, oh, I want the one that has h in it, so I want this version of the cosine law. H squared equals w squared plus m squared minus 2wm cos h. And as soon as I write down that formula, me personally, then I call up my favorite pizza place, Pizza Hut, and I go, send the pizza. I'm going to be done this question in just a second because I've got a formula with h in it. I'm good at rearranging. And if you're good at rearranging, you're like, okay, this is no problem. And you can solve for it beforehand, but you don't have to. I could sub the numbers in right now. It's a lot of numbers to carry around. It'll be a big sloppy mess. So I like solving it beforehand. Yes? I'm going to do that one step at a time to really demystify that formula. If I wanted cos h, the first thing I would do is go h squared minus w squared minus m squared equals negative 2wm cos h. I'd move the w squared and the m squared over to the other side. And I don't like how that's appeared on the screen there, so let me just get my eraser and just tidy that up a little bit. There, oh, that came out good. See, that's not too exciting. I just moved w squared and m squared over. I'm trying to get h, the big H, by itself. Now, one more thing I got to do to get h by itself is divide by this monstrosity out front here, this negative 2wm. So I'm going to go h squared minus m squared minus w squared minus m squared all over negative 2wm equals cos h. There's the formula. But again, you've got to practice your own way. You're like, nope, I just write down the formula and I plug it in. I like that. Okay. I like rearranging it. Okay. Or I like subbing all the numbers in, and once it's all in number form, then I can move it around, and I feel better about moving the numbers around. All three are great options. So, h squared, 7 squared, minus w squared, 5.6 squared, minus m squared, 4.8 squared, over negative 2 w 5.6 m 4.8. That's equal to cos h. So, in my fancy calculator, put that all in. 7 squared minus 5.6 squared minus 4.8 squared all over negative 2 times 5.6 times 4.8. Oh yeah, I still got to inverse cos it, okay? And this happens all the time in trig, where you forget one step, and then the answer is like, what? And when that what happens, don't start erasing things. Just sit back for a second and go, what did I forget? What did I miss? The answer's gone ridiculous on me. So what I really want is h equals cos inverse, and you formula people, who I love as well, this is the way you'll start, and you'll just cos inverse that whole thing right from the beginning, and you'll get h equals, I'm going to use my fancy answer button again, cos inverse answer equals 84 degrees. Did you get 84 degrees? You were happy. Now, on purpose, I've tried to teach that and giving you some freedom here. You can do it my way. You can jump right to here if you like the formula. Yeah, there's the line. That formula, people, that's where they'll start. Or you can sub numbers in right off the hop and then solve for what you're after. You don't see that as much anymore. You usually see either formula people or pre-rearranged people, but hey, you do you. You have to say question. The next one's my all-time favorite. Because it makes people know, it makes people realize how we measure the heights and how far things away, how can we possibly come up with these things, and it's actually quite easy. Here is the situation. There's a cliff on the other side of the river, and we want to know how high it is without crossing the river. So what we do is we stand there at C, right there, and we measure the angle upwards to the top of the cliff using what's called a clinometer. A clinometer is just a device. All it has a little weight in the bottom, and you just hold basically a big protractor in the air, and the string hangs down and shows the angle. You could build one out of a protractor, a piece of string, and a stone. Yeah, that's how easy it is to build one of these things. So you measure the angle to the top of the cliff. Then you go out however far you want, and you make another spot on the ground. and you just measure the distance between those two and use your clinometer to measure the two angles at the bottom here. Notice you're on this shore the whole time measuring the height of the cliff on the other side. Huge astronomy applications here to be able to measure the distance between stars and planets and how big is Jupiter and the whole thing. It's all done exactly like this. Determine the height of the cliff shown. This question shows up in your test and you're like, okay, I'm looking at triangle ABC, Mr. Todd, and I got a 33, but I don't have another length. I'm like, I know. You don't have another length in the right angle triangle that goes up to the top of the cliff. The only length I've got over here is in this other triangle, which is not right angled. Now I said it in another lesson, but let's make it very clear. What's the most important side in this question? And it's not AB. CB. Yeah, I need a fancy color here that's going to appear on this colorful diagram here. I'll go with orange. Let's see if orange works pretty good. Yeah? Color that in. That's what you paid me for to come in on Friday morning, to tell you that that common side, that's the side you really want. If you can get that, everything's going to be okay. Because it's in both triangles. Yes? That's its big advantage, is it's in both triangles. So, redirect your attention to the oblique triangle that's in the river. And go, can I get the orange side? Well, it's non-right angled, so no Pythagorean theorem. No SOHCAHTOA. S8, Peter's a step ahead of us. He's put SATT first, maybe. Where he's like, before I even get started here, let's check SATT. The only danger with that is you got to make sure you circle angles when you go to use them, okay? So if you're going to find angles first, I love it. Just make sure that when you go to do SOHCAHTOA, you circle the angle you're going to use. He says, I can find this angle in the bottom here, 180 minus 62 minus 50. You get 68 degrees? Why is that such a big deal? Now I've got a matching pair. See, this is that one I talked about in the other class where I was like, what happens if you don't have a matching pair? Well, cosine law, unless you can get that third angle, which I could here. So now I'm going to use the symbols in the diagram, okay? Some of you were doing that in the double angle question, and that really helped you on the quiz. With the quiz, you're about to get back, right? So as soon as I finish, you're like, Mr. Todd, the quiz. Mr. Todd, the quiz. I'll give you the quiz back. Those of you who haven't wrote or want to rewrite need to let me know so I make enough copies for Monday. Okay. Here it is, using the symbols I see in the picture. BC over sine of D equals CD over sine of B. I know that doesn't look like the sine law that was in the formulas. That's application of it going, okay, it's always opposite pairs. BC over sine D, CD over sine of B in the picture. But I must tell you, if I'm being quite honest, that's not what grade 11s and 12s usually write. And we let them away with it. Usually they write this. They don't get caught up in the individual symbols. They just go BC over sine 50. They fill it right in. That's almost easier to follow than always going with the fancy symbols. Just pairs. BC with sine 50, they're just looking going this side with that angle, this side with that angle, always opposite pairs. And this time, instead of doing the cross multiply, I'll try to convince you that you don't have to. If you put the unknown top left, you don't have to cross multiply here. You can just go BC is equal to 160 over sine 68, and I'm just bringing the sine 50 over and multiplying by that. And now I can get BC, which will make me very happy once I have it, 160 over sine 68 multiplied by sine 50 equals 132.2. Put it on the diagram. Put it on the diagram. 132.2. And just to help with the thinking, why is that such a big deal? It completely changes the whole dynamics of this question. Now we got that common side, right? And now we're into the triangle ABC. Now I can go over and work in triangle ABC and do this. Is it a right angle triangle? Yeah. This time it is. Pythagorean theorem is in. That's not helpful, but SOHCAHTOA is in. I'll circle this angle. And I go sine, cos, tan. I've got adjacent. I want opposite. Tan, yes, good, tan. Lots of times, inaccessible distances, tan eventually rears its head, right? So tan of 33 is opposite over adjacent. So tan of 33 equals AB, which is what I want, over 132.2. And it might have been a couple days since you did one of these. Now what? Yeah, it is cross multiply. But we might be at, some of you, I really hammered away on cross multiply, but it's possible you look at this and go, well, I'm just going to bring the 132.2 over and multiply by that. And that does the same thing. So again, if you're cross multiply and you're happy cross multiplying, then just do that. But just be aware once in a while you'll see someone just jump ahead and just write this without the cross multiply because they can just see what's going to happen. That's if the unknown's in the numerator. If the unknown's in the denominator, you got to cross multiply. That's why some people don't like that. They're like, I'll just cross multiply. I don't want to think about when do I do it, when don't I do it. And I like that too. Do you get 85.9? Now, how accurate is this? As accurate as your clinometer is, and as accurate as your ability to measure the CD. So if I was actually on the other side of the river, how well do you think I can measure the distance along a river? Within half a meter or so, maybe, is the best I can probably do and be accurate. The angle within a degree or so, maybe, is the best I can hope for. So no, this isn't going to be perfect. But astronomers, they've got devices that they can get these angles down to decimal places. They can get the distances down to meters. And you can imagine, if we got the distance to Jupiter down to meters, we'd be pretty happy. Yes? So yes, this can be as accurate as our devices are. I actually think your phone has a chronometer built in. There's a way to turn it sideways and measure angles. Yeah? So you look through it. I don't know where it is anymore. It's in. It used to be in. It's on the Compass app, yeah. And there used to be a setting you could turn it sideways using your phone as a clinometer.
There's a measure app, and you go level, and it'll show you.
Measure, he says. My measure takes me right into settings. There's certainly plenty of third-party apps that you can get on your phone and easily turn your phone into a clinometer. Now, can it do better than a degree? I don't know. That comes down to holding your hand. But you can imagine with technology this can be done. Lasers is what you need. Yeah, a laser sighting system to the top of the cliff. Yeah. All right. The captain of a boat leaves the marina and heads due west for 25 kilometers. Which way's west? I don't know which way's west. How do you remember this? Never eat shredded wheat. Is shredded wheat still a thing? Really? I thought it was just a torture device of the 80s. It was awful. All the cereals that are out there, and my parents are buying me shredded wheat. It's literally called shredded wheat.
I don't think that compass is
So, boat captain, first goes that way. Due west, 25 kilometers. Okay? Then he turns and heads his boat north, 30 degrees east. What the heck does that mean? It's actually telling you what to do. Look, no, hey, watch, you got to watch me do it with mine. North, 30 degrees east. Yes? There's where it is. There's north 30 degrees east. And if you've never seen that before, and that's weird, I know, but this is what they use, what boats and planes use. They talk like this, north 30 degrees east. It's telling you, where do I start looking, and then what angle do I go in what direction? And it said, start north, and then go 30 degrees east. For reals. How far is the boat from the marina? So this is, the boat started here at the marina, went that way, 25 kilometers, then 30 degrees, 20 more kilometers, and now I got to draw on the actual distance from the marina. There. There's my unknown. X. I don't have any angles in the triangle. There's no chance here. 30 minus 90 or 90 minus 30. I can get this angle in here, I hope, pretty easily, because that's at 90 degrees. And that's the nice thing about these measurements that are measured off north and east or west, is that usually you can figure out the other angle you need. Well, can anyone tell me what I'm going to use here and why I'm going to use it? It's not a right angled. Oh, they came to it here in the front row. There's a whole bunch of words. I didn't hear exactly what they said, but I definitely heard non-right angled. Then I heard something about, how did you decide it was cosine law? He can just look at it now. It's the special one. When the angle's between the two sides like that, that's cosine law. But maybe you don't remember it that way. Maybe you remember it like there's not a matching pair here. I don't have a side in its matching angle. So here we go. X squared equals 20 squared plus 25 squared minus 2 times 20 times 25 times cosine 60. Ms. Ty, you didn't label anything. Are you saying we don't have to label anything? I think there is a moment with these where we get to the point where we can just hammer them in there because we know the pattern. But I don't want to scare you. So I'm going to call this little m. I'm going to call this big X. And I'm going to call this X. I'm going to call this little n. And I'm going to call this big N. And I'm going to build the formula for you so I'm not freaking you out here. X squared equals m squared plus n minus 2mn cosine x. Yes. Yes. Mr. Todd, I really want to be cool. I like this. Typing it in my calculator once. Move. If you want to do that, then you have to do this. That move gets you your calculator badge at Girl Guide Camp. Is Girl Guide still a thing where you go and you get different badges for different things? There's how you get your calculator badge. I'm not saying do that. I'm not. I'm just saying that's what you'd have to do if you want it typed in all in one step. And so when you go to type in, you got to go square root, and you got to, oh, mine does a square root and make it, and jumps underneath the square root. Yeah, if it does that, or if it opens a bracket on its own, then that's okay. If it doesn't do that, then you got to force it to, you got to put a bracket in there. Anyways, 20 squared plus 25 squared minus 2 times 20 times 25 times cosine Why is my brain telling me it wasn't 60? It is 60? Is 60 right? 5 root 21. There's obviously more to the story here when the calculator does stuff like that. And we'll get to that story in grade 11. For now, let's get the decimal. 22.9 kilometers. Did you, does it seem reasonable? 20, 25, and 22.9? Yeah, reasonable answer. Did you get 22.9? If not, try typing it again. If you're still having trouble with your calculator, bring it over and we'll talk about it and we'll get it worked out. Do you have any questions? Some wonderful word problems. The word problems are very repetitive. They won't seem repetitive the first few you do as you sneer at this list. But as you do more, you start going, these play out the same way every time. There's only so many ways we can ask the question, right?